All right, learning targets 7 and 8. 7 is explain operations on irrational and rational numbers. 8 is solve equations using square roots. So first, just a few definitions. The square of a number, and we talked about this a little bit with our last learning target. The square of a number is the product of a number and itself. So for example, x squared is written like this with the exponent as the 2, x to the second, or x squared, and that's the same as x times x. And again, that was something that we sort of talked about a little bit with learning target 6 when we were doing some multiplying of polynomials. The square root of a number is the opposite of squaring a number. So every positive number has 2 square roots. And you probably knew about the positive one before, but that there's also a negative square root. So for example, the square root of 36 could either be positive 6, it could also be negative 6. And so it's sometimes written as this plus or minus 6 to indicate both the positive 6 solution and the negative 6 solution. So our first example is find the side of a square whose area is 81 square inches. And I don't think that this little square is in your notes, so if you want to write that in to kind of see it visually, that might be helpful for you. So finding the square root of the side, or finding the side of a square whose area is 81 is exactly the same as finding the square root of 81. And so if we have the area as 81, we're finding the square root of 81, which most people know as 9. But again, if you go back to our previous definition there, it can have a positive answer and a negative answer. So there are actually 2 square roots. This could be positive 9 or it could be negative 9. Now, in the case of a square, if this were actually a physical square, it would have to be positive 9 because you can't have a side length of negative 9. So in this case, this side length would have to be 9. But the square root of 81 itself has 2 answers, positive 9, negative 9. Okay, and the reason for that is if you take a negative 9 and do the opposite of square root, so square it, so multiply it by itself, negative 9 times negative 9, the negatives cancel each other out, and this just becomes a positive 81 again. Okay. So in the second one, we're again finding the side length, but this time the area is 5. So we're going to find the square root of 5. And if you punch this into a calculator, you will get a pretty long decimal, somewhere between probably 2 and 2.5 or so, somewhere in there, maybe in the 2.3 range. If you are solving an equation and you get to something like this, I would rather that you leave this as the exact answer than give me that whole long decimal. That whole long decimal doesn't really mean a whole lot to me. So if you come down to something like this, the answer I would rather have you write as simply plus or minus square root of 5 instead of plus or minus the 2 point whatever. Okay? So the more exact that you can be with your answer, the better. We have some more definitions. So we have all sorts of classes of numbers. And we'll go through the definitions first, and then I'll kind of explain this chart over here. So first is an irrational number. An irrational number is a number that cannot be expressed as a ratio of 2 integers. In decimal form, it has an infinite number of digits and does not show a repeating pattern. A rational number is sort of the opposite of that. A rational number can be written as a ratio of two integers. Or, in other words, that whole ratio of two integers thing basically means you can write it as a fraction. 3 over 2 is a rational number because you can write it as a ratio, in other words, a fraction, of two integers, which is what our next definition. Integers are any of the basically whole numbers, but include the negatives. So any number -3, -2, -1, 1, 2, 70, -99. The whole numbers are a smaller group than the integers. The whole numbers are the integers except none of the negative integers. So a whole number is basically a positive integer, or 0. And then the natural numbers are exactly the same as the whole numbers, except no 0. So we can kind of order these groups from smallest to largest, going up this list. Okay, so the smallest group of numbers is the natural numbers. The whole numbers are slightly larger because they include 0. The integers include all the negatives, so that's a much bigger group than the whole numbers. And then the rational numbers are a much, much, much bigger group than even the integers, because you can take any of the integers, write any fraction that you want, and that fits into rationals. Okay, so in this little diagram over here, we have the irrational numbers here on the left. And some examples of irrational numbers are the square root of 7. If you type in the square root of 7 into like a calculator or something, you'll get some crazy long decimal that's probably close to 3. But not quite 3. So it's going to be like 2 point and then long list of decimal numbers that never repeat. And if your calculator could go on forever, it would. Pi. Most people see pi as just 3.14, but there's tons of other digits after that, on and on and on and on and on. And so since it has this unlimited list of digits without any repeats, this number is irrational. Down here with 3 plus square root of 5. We talked about how square root of 5 was this crazy long decimal, 2 something. If you've got your decimal 2 point something, and you add 3 to it, it just becomes 5 point decimal. So this is still an irrational number, even though you've added 3, which is a rational number. The rest of this just shows you the different groups. So again, natural is our smallest group of numbers. Whole numbers are all the natural numbers, but this time including 0. The integers include all the whole numbers, except now we've got some negatives in there. And then the rational numbers are all numbers that you could ever write as a fraction, including all the integers, all the whole numbers, all the natural numbers. Okay. So before class, what I would like you to do is add a number to each category in here. So come up with your own irrational number, add it in here. Come up with a rational number, add it here. Come up with an integer, a whole number, and a natural number.